Move the crane to position 3. Watch the tension on that line. We can't afford any slip-ups this close to the surface.
Check the load-bearing specs on the tablet.
They're holding steady, but watch the starboard winch. We did it!
Look how big it is! It's finally here. What an amazing sight.
Lowering sequence initiated. Hold at 5 meters.
Confirmed alignment is stable. Cleared to proceed.
Roger that. Bringing her down slowly. All clear.
The structural integrity looks good from here, but keep an eye on that flap mechanism.
They're bringing the external power unit now. Let's check the thermal sensors on the nose first.
The structural integrity report on the fuselage looks promising.
Reorganization of the scaffolding will allow us to start the wing inspection tomorrow. The 3D data highlights the extent of the corrosion around the access panel.
Yes, we're looking at significant material loss.
Structural integrity around the wing spar here seems different from the original schematic. We need to verify the material gauge on the recovered fuselage.
This corrosion near the access panel needs a yellow tag for now.
Agreed. But this spar right here, that's definitely red. Log it.
We need to isolate the forward fuselage section first.
Agreed, but watch the wiring conduits near the spar.
The challenge lies in creating these sterile cocoons around the sensitive components, protecting them from the hangar environment.
Bring it up another 2 feet. Looks like we have some corrosion on the lower stringer here.
We need to focus on this critical path item in phase 3. Any bottlenecks here will throw the budget off track. Clear on the left.
Confirmed, 2 meters up.
Check alignment on the starboard side. We have a slight drift.
Correcting now. Laser guidance is stable.
Hoist, bring it down slowly. We have significant corrosion here.
Copy that. Proceeding with caution. The contamination is severe.
These red zones indicate significant stress fractures near the joint.
Yes, the depth profile confirms the severity. We need to recommend replacement.
This cutting-edge technology is vital for recreating components that no longer exist, bridging the gap between artifact and modern manufacturing.
Temperatures holding steady at 980 Celsius.
Acknowledged. Initiating final sequence.
Integrating these new digital boards into the vintage housing requires absolute precision. It's how we bridge the past and the future of flight control.
Look at that thrust, it's beautiful.
All parameters nominal, Doctor.
Excellent. The restoration is a success.
The alignment here is critical for the fatigue resistance.
Agreed. We need to maintain pressure to smooth out any trapped air.
That's creating. Fit is perfect. Ensure all connections are seated before we lock it down.
Roger that. Looking good back here?
Calibration sequence complete. All angles verified.
We have seepage at the main coupling, confirmed with the UV dye.
Torque wrench set to specs. Confirm green on the indicator.
We have a solid lock. Pressure equalization is complete.
Confirmed. The fit is perfect. Proceed with securing the housing.
We have synchronization on the forward jacks.
Maintaining stability, reading is nominal.
Keep tracking down, steady. Clear on the starboard side. Okay, set it down.
Hydraulic pressure holding steady.
Sequence complete. Green light on all indicators.
Pressure is steady at 3,000 psi.
Confirmed on the readout. System integrity is good.
Ailerons to full deflection, holding for 5 seconds. Pressure steady. Data confirmed. Flow rate is exactly as expected.
And the pressure is stable.
Ground control, this is Constellation 1 at 121.5 for a radio check, over.
Roger that, Constellation 1. Loud and clear. Verify all warning indicators. Amber, green, red. Confirmed operational.
Alive.
Look at that, spool up!
Elevator and rudder systems, check. Landing gear visually inspected, check. All systems go.